Hey guys, we're going to continue on in our pneumatic discussion. This is part of our fluid power class. And we've talked a little bit about what air compressors are and what they do for us and the differences between hydraulics and pneumatics and all that kind of stuff. And we talked about Boyle, Charles, and Guy Lussac. We discussed their principles, and we're going to start putting those into play here shortly. But we're going to keep rolling. We're going to talk a little bit more about air compressors. Now, this is the reciprocating. We talked about two different types previously. We talked about the screw type and the reciprocating. I'm going to use reciprocating on this example. It's going to apply both to reciprocating and the screw type, but it's a little bit easier to visualize. Okay. So what happens with an air compressor, a lot like this gasoline engine example I used earlier. Okay. The air compressor takes the air into the chamber and reduces the volume of the chamber. Okay, that's real important right there. It reduces the volume. Okay, so our volume is this area above the piston, regardless of where it's at. That's the volume. Okay, and it's sealed with its rings, its piston rings. Okay, and it pulls down and it kind of creates a vacuum, you might say. Okay, and we'll go back to this little example here. Remember this? Okay, this is where the guy is sucking on the straw. He's not sucking water into his mouth. He is lowering the pressure inside his mouth to below atmospheric pressure. And what we say about fluids, it always seeks a lower pressure. So he's creating a lower pressure than the 14.7 per square inch, pounds per square inch in the atmosphere. He's lowering that below 14.7 pounds per square inch, and the atmosphere is shoving that air, that fluid through the straw into his mouth. He's not sucking in there. The atmosphere is doing its job and shoving it through that straw into his mouth. Same thing's going on here. Okay, when the cylinder pulls down, when it pulls down, it is lowering the atmospheric pressure, or the pressure inside this chamber, I should say, inside the cylinder, to below atmospheric pressure. So the atmosphere is shoving the air into that cylinder, into that chamber right there. Okay, so when the cylinder strokes down, the pressure in the cylinder drops below atmospheric. Atmosphere shoves it in there, and then on the upstroke, okay, as we start going up, okay, the volume. Remember, this is where I told you it's important. The volume of the chamber decreases. Okay, it's reduced, and the air becomes pressurized. So going back to Boyle's law, remember he said that he said it actually. Pressure and volume are inversely proportional. This is a prime example. Okay, this is what we're talking about. We are reducing, lowering volume, and our pressure goes up. So there's that inversely proportional relationship that Boyle was talking about. Okay, so this creates our pressure. Again, a couple things I want you to take away from this is, number one, it's not sucking air into the chamber. We are reducing the chamber's pressure to something below atmospheric, and therefore atmospheric shoves it, takes over. It goes. It's always seeking from higher to lower. It shoves that air into that cylinder, into that chamber. And there, our piston will compress or reduce the volume. And Boyle's law tells us that if volume is reduced, then pressure is going to go up. Okay, so that's how we create our pressure. Same thing applies with a screw type conveyor too. Don't get me wrong. This is not just for the reciprocating. Remember, we said our screws got tighter and tighter, and the volume at which it's packing that air in is starting to decrease and decrease. The volume is getting smaller and smaller, and the pressure is increasing, and it just charges out of the pump into our system. So it works for the screw conveyor. The screw compressor the same way it does with the reciprocating. Just want to make sure you understood that. But what we are trying to create is flow, and this transmits the energy to all of our components from the compressor. Okay, travels through our conductors. The proper name for our piping or tubing is still called conductors, and it does the work needed. Okay, now as I said, all of this flow happens is because we are going from a high pressure on one side of our device to a low pressure. And this little valve, this is just a ball valve that I got you, but it's just to explain the concept again, is that we've got pressurized air right here. Our compressor is hooked up, and we've got this valve closed. We've got no flow, okay? So there's nothing on this side. Pressure is built up, a lot like in hydraulics we talked about. Pressure is built up. There's no pressure on this side to counter it, so it's going to immediately, when we open the valve, it's going to seek a lower pressure, This is the lower pressure on this side, and it's going to run. And then, of course, when we have it fully opened, and if we have it blocked off over here, for example, we would have equalized pressure. We'd have no flow going on here. But my point is that our flow is always, our pressure and flow are always trying to go from a higher pressure to a lower pressure. Okay? So, I put this up here as an example. If you've ever used one of these, or if you've ever gone to one of those free air dispensers there in like a gas station or something like air compressor, you can put air in your tire. You'll hear the hissing in that tire, okay? And what you're hearing is you're hearing that air evacuate from this chamber here, all right? This reservoir. Now, remember, you can't do this with hydraulics because you can't compress it into a chamber and then discharge it like that, okay? But if you ever listen and you hear the hissing stop coming out of the air from the tank, you ever hear that hissing stop, that's what's going on is the flow has stopped and your pressures have equalized, okay? So when you have equilibrium on both sides, you stop flowing. But maybe next time you're there, you get some air put in there, you'll hear it hissing, and then when you stop hearing it hiss, it means the flow is done all it's going to do, okay? All right, so you're not out of air, okay? It's just that there's no differential from one side to the other because you can still have 50 pounds of air pressure in this tank, and once this tire has 50 pounds, they're equalized. So anyway, just something to kind of make things relevant for you, okay? Now, we're talking about flow, but there's one area that we've not talked a whole lot about extensively, and you're going to get into this in AIT 1402 and 1403, your basic pneumatics and basic hydraulic classes. These are the fundamentals. One of the things I want to talk to you about in flow is how we direct flow. We're not going to get real extensive in directional valves with this in this class, but you know you've worked with them a little bit in the class in the lab, and so you're shifting a valve and you're making fluid go here and making fluid go there and it's returning and things like that. But if you want to break it down just a little bit for you, okay? Now this is a hydraulic. This is a hydraulic valve, and the reason I know that is because if you remember we talked about how a pneumatic system is not a closed loop system. It exhausts its spent air or return air out into the atmosphere, okay? Well, we've got a pressure port, which could be pneumatic or could be hydraulic. But here's the giveaway there. This is going back to tank. We don't go back to tank in pneumatics, but I'm just using this for an example. This is our block for our directional control valve, okay? And here it is in our symbol right here, okay? This is our directional control valve, and I'm going to get into this just in another second here. What we do is we shift the spool inside that, and it redirects the pressurized air either to this side or to that side, depending on which way we shift it. Another thing that I want to talk to you about is this pressure regulator right here. What's interesting is this is a pneumatic pressure regulator, and you'll notice that as opposed to the hydraulic, there is no path for the fluid to go from here to tank. We don't want that fluid to go to tank unless our pilot pressure, remember the symbol there, the pilot pressure line, unless our pilot pressure says, hey, I'm building up too much pressure, got to relieve it, then we're going to give it a path to tank. Okay? A little bit different in a pneumatic regulator. We are allowing that pressure to go through, or that flow and pressure to go through here, and here we're saying 70 psi. Okay? I think I got a better example here. Here we go. Okay, this is blown up. So we are going through our fluid conditioner. It's our diamond-shaped symbol that tells us we're conditioning it, our fluid or our air. In this case, we're conditioning it by filtering it. Okay, but we're allowing this air to flow through onto our device, okay, and through our system, and we are monitoring the pilot pressure on the back side. So if the back side here gets too much air pressure, that pilot pressure is going to lift this off of its seat, going to stop the flow coming from the compressor, all right, and it's going to dump it to atmosphere. A little bit different configuration or a look to it. You see this one's blocking it off, and we want to, when in the case of too much pressure, we give it a path to flow back to tank, and on this one here, or the pneumatic one, we allow it to flow, and we'll dump it from the system and then dump it right into atmosphere, okay? Just giving you a little heads up. Going back to symbols, we're going to keep working with these. Again, diamond shape. Diamond shape over here, we're conditioning this fluid. We filtered it over there. In the conditioner here is we're going to add a little bit of oil to it to keep the cylinder seals and the valves lubricated and in good working order. And so we use a lubricator for that. You should know a gauge, pretty easy. This is a manually adjusted pressure regulator. It's got spring pressure, okay? And we monitor pilot pressure, okay? I take that back. I want to stand corrected. That is not adjustable, okay? We are using the pilot pressure, but you'll notice there's no arrow there going through here at the slant that tells us it's variable or adjustable. So this is a fixed value, and whenever the pilot pressure hits that, whatever the fixed value is, it will lift it up there and dump it in the atmosphere. But some more symbols for you. And again, here is where I want to talk just a little bit about the valves, okay? We have a valve. I'm going to give it this side so you can see a little bit better. And this is from our supply line. And you got two sets of arrows, and they are redirecting the air. They're directing it in opposite locations from each other, okay, or opposite paths. We've got a pressurized air, okay, and it's going to flow through here, through this arrow right here, and it's going to get on the back side of that piston, okay. We're going to start filling up that volume of the cylinder, and it's going to press the cylinder down. We're going to extend it, and the air will exhaust through this arrow right here, okay, this part of the spool, and out into atmosphere, okay. What happens is, if we were to shift this valve, okay, we have a little solenoid valve right here, and we were to shift it, we would replace this set of arrows with this set of arrows. So if you can follow along with me here, okay, we'll have our pressurized air coming up to this one, okay, and this one, this arrow would slide into place, and we would be pushing pressurized air from our system, from our compressor to this side. We're going to pressurize this chamber of the cylinder. We're going to retract it. The air that's behind the piston here is going to exhaust. And again, we're going to go in a different path, okay, with this arrow right here will now be here. It's going to go straight across out into atmosphere. So that's how the directional control valve works, the path. Again, you'll get into these extensively in 1402 and 1403. There's all kinds of variations. So there's 5-4 valve, 4-3 valve, things like that. So I just want this, just right now for this, we are just talking about how it directs the flow. And there's a lot of variations to valves that we are not going to get in this class. But like I said, just want to kind of make you aware that when you're over there shifting the valves, that's what's going on, okay? But again, going back to our pneumatic system, our air is stored under pressure in what's known as a receiver, okay? And here is a graphic, and this is the receiver. People call it the tank, air tank, okay? Regardless, it's the receiver. That can have, sometimes you can have more than one receiver. So, you know, a lot of times you don't call it a compressor tank when you've got more than one, but it's known as a receiver, and that's where the air is stored under pressure, ready to use. And the thing about this is you can have pressure in here and this compressor not run at all. Okay, you might be able to you do a few functions without it ever kicking on and with enough pressure in there. Not so with hydraulics. You'll never stroke anything. You'll have an accumulator pressure, but it won't have the volume that a receiver will. Okay, it can do a little bit, but you have a lot more energy packed into this receiver here than you do typically for a hydraulic system. But that's it in its position, I mean in its context, I should say. But anyway, that's just kind of a picture there. For right now, we're going to shut this one down, and we're going to start getting more and more into the different laws, and this is where you got to take the notes. And I'm going to make it easy for you. I'm going to show you how to do it in an easy way, in an easy manner. Again, I'm not trying to teach you math. What I'm trying to teach you is how the pressures and the volumes, and we're going to introduce temperatures, how they all come together and impact these pneumatic systems we're talking about, okay? So let's shut this one down and start looking into some of the different laws from the different scientists that we're going to be using to apply. So other than that, let's shut it down, and I'll see you at the next video.